All right, so let's start. So today I'll be presenting this paper called titled NL2Contact, Natural Language Guided 3D Hand Object Contact Modeling Using Diffusion Models. So this paper was published in ECCV 2025. So what it what the paper does is it models the hand object contact and refines 3D poses that aids a grasp and synthesis. So, and the traditional method relies on geometric constraints, which lacks controllability. So, in this paper, they use text to control the contact. So that's how they get away from the geometric constraints and all, and in their traditional architectures. And like I said in last part, like it adds the natural language description, and that's how they model the contact precisely. And for generating the contact, they use stage diffusion. They use two stages of diffusion to generate realistic and controllable 3D and object contacts. We'll get into details about it in later sections. So the key contributions of this paper is um, they show the new task of 3D hand object contact modeling guided by natural language. Uh, for that, they proposed a data set which has fine-grained textual description of contact, which is generated by LLMs, in their case, ChatGPT 3, and they have stage diffusion models of two stages. Um, they have stage diffusion model of two stages, and which helps to generate uh, precise head-object contact maps. And the last part is they have text-to-hand object fusion network, which extracts the contact details from point cloud and text together. They take the input of point cloud of hands and objects, and then from the text, they manipulate the hand and object, and also generate the contact for that. So the motivation for this work was contact modeling improves hand pose accuracy in animation, VR, and robotics. Existing method use geometric constraints but fail to model real-world gross variability. So, and language-based descriptions allow function controls over the head-object interaction. So, let's shown here. Uh, if we can describe the interaction in more granular fashion, then this method can generate those grasp better than the method which can just generate based on geometric constraints. Right. So let for that that's proposed a data set called contact described data set, which actually extends an existing data set called contact pose with rich and natural language annotation, and they contain 2.3K unique grasp and unique grasps of 25 household objects. They have three level of annotations. The one is high level, which is basically describing the high level task on that particular scene. In mid-level annotation, there is a bit more details. In low-level annotation, they have further details. And all three levels of annotations are generated using ChatGPT 3. Yeah, so like that, these are some examples of that. At high level, mid-level, and low level. You have seen it before, so I'll just skip this slide. For the method, they have mm, mostly three main components. First, text-to-hand object fusion, which extracts the hand-object relations from text and point clouds. Next part is stage diffusion models, which generates hand poses first and then defines hand-object contacts. And the last part is the uh, optimize contact iteratively for hand pose using contact constraints. So this is the overview of the method. So the method from the figure looks a bit more complicated, but if we I'll get into each section. So there are three sections: text to hand object fusion, stage hand object fusion, and optimization. So what if you really want to have a high level, very high level overview? The in this method, what they do is they take input of an initial hand pose uh, and the text accompanied by it. And the last one is the object mesh. So object, not the mesh, the point cloud. So with these three, they manipulate the input and point clouds and the object point clouds to a certain uh, to the hand pose and object pose uh, of the desired locations of desired poses is described here, and later they optimize the poses for contact, and at the last part they get the hand object generated hand object meshes. So the first one is uh, contact maps modeling. So what is contact map modeling? So for if we think generally, the contact map modeling can be uh, defined like this, where n is the number of vertices for number of vertices for hand for contact map of hands, and this n is the number of vertices for uh, contact map of the objects. So this in this word, they optimize both in the third section, in the last part. Um, so first part in this section, what they do is they extract the hand and object relations from natural language and 3D point clouds. They take the input of hand pose, H, object point cloud O, and the text description, and they use the multi-headed attention module to fuse uh, the text and the poses to get the final post required for that particular description. And then if we get into the individual part, like the way they use text and hand together is they encode hand pose using vposer and an autoencoder for human pose. Then they encode text using BART model to get the semantic features. And also, like explained in the last part, they use multi-headed attention to align text feature with the hand pose. For text object fusion, they use PointNet++ as they take the input of point clouds. They combine object features and text to guide cross refinement and uses additional binary per point feature to distinguish between hand and object points. For the diffusion model, they have two stages. In the first stage, they generate hand poses based on text and noisy input. In the second stage, they predict the precise hand object contact using object point clouds. So this, in the first stage, when let's say the hand pose is encoded as variable x each O, and the Gaussian noise uh, then the Gaussian noise is added, and the training objective is this. Uh, the point is for this part. The point for this part is the generate hand pose for a particular uh, this text description in this part in the first stage, and in the second stage they generate the contact map, which is generated. Yeah, it's the second part, and they generate the contact map based on the text. And in the third part, what they do is they optimize they optimize poses based on contact map of hand and object both together, uh, based on this objective function. where everything everything is annotated here. So like it's CH is predicted contact map. This is ground truth. This is predicted object map prediction of the object map object contact map, and this is the GT contact map. And the last part is the penetration loss. They also have add some penetration loss to uh, for the flickering issue. So the summary of the methodology is uh, they have a fusion network which extracts the relationship between hands and object in text, and they have the diffusion model which generates the hand pose first, and then it refines the contact maps. In the third step, they refines the hand object interaction to ensure the realism. So they first generate the contact. They first generate the hand meshes and object meshes. Then they generate contacts, and based on contact, they optimize the poses of hand and object together. And that is it basically for the overall summary of this uh, uh, work. Since they're using text to control these interactions, which enables them to control uh, the interaction of hands and object more realistically uh, compared to other existing methods. So for that experiment, they used their own dataset contact describe, which they made from contact some other datasets from contact pools. I forgot the exact name, and used ChatGPT to generate the descriptions. And for testing, they use H3D. Uh, for metrics, they use MPJPE, contact converge, and intersection volume and graph diversity. So they show here and their method performs better than most existing methods, all the existing methods. And these are some qualitative results for their method. So what this shows here is their method is more granular. By granular, what they mean is that they can generate interaction between each fingers compared to the previous architectures where they fail when the interaction is too granular, like in finger level, like two fingers are opening a bottle or something. In those cases, the previous architecture suffers a lot, but in their case, their architecture it's better since their interaction is controlled by mm, text, so they are more granular. And so, in conclusion, in this paper, what they did is they introduced the text-guided 3D hand object contact modeling. They developed a contact descript dataset, which has more detailed textual annotation. And thirdly, they have proposed a two-stage diffusion models, which allows them to generate more realistic and controllable contact. And the last part would be like they have proposed this work for static scenes to extend this work in future. Maybe future research can focus on dynamic contact modeling for robotics and everything else. So that's could be an interesting application. So that would be it for today for me. Thank you for listening.